This is Geometry, section 7.1, Ratio and Proportion. So this section is really just a review of Algebra 1, getting us ready for what's in the rest of Chapter 7. But this section is really not much geometry, it's mostly just algebra. So what is a ratio? A ratio is just a fancy word for a relationship. So if I say the ratio of A to B, I'm talking about the relationship of two things, A and B. We write it either as A over B. Usually we see it this way, written as a fraction. We also might see it as A and then a colon and then B. We read that as the ratio of A to B. So, simplifying ratios. If we have something like 6.4 meters to 160 centimeters, we're trying to compare those two things. First thing we need to do with something like this is make sure we have the same units. Okay, so whenever you're comparing a ratio of two measurements, you need to have the same units. So it says here that 1 meter is equal to 100 centimeters. So we're going to change this 160 centimeters to meters. The way we do that, which hopefully you remember from your physics class, is using a unit conversion like this. So we know that 1 meter, like it says right here, 1 meter equals 100 centimeters. So we line it up like this. 160 centimeters is what we want to change. We want to change it to 1 meter. These units cancel out because I have one on the top, one on the bottom. This is the unit I want to end up with. So I have 160, and this means I divide 160 by 100. When I do that, we get 1.6 meters. So 160 centimeters equals 1.6 meters. So I can write this as 6.4 meters over 1.6 meters. And then if we simplify that even further, 6.4 divided by 1.6 is just 4. 42 minutes compared to 2.3 hours. So this time we'll change hours to minutes, and we know that, so if this is an hour, we know that there are 60 minutes in 1 hour. So again, we want the hours to go on the bottom here because we want that part to cancel out. We want minutes to be left. So this time, since both these numbers are on the top, we multiply them. When we multiply 2.3 hours by 60 minutes, we get 138 minutes. And on the top was 42 minutes. So 42 minutes compared to 138 minutes reduces to 7 to 23, or 7 over 23. 2 1/4 years compared to 36 months. So we can change either one here. We can change 2 1/4 years to months, or we can change 36 months to years. Might be easier to change this because we know there's 12 months in 1 year. So 36 months would just be 3 years. So we have 2 1/4 years compared to 3 years. This would reduce, if we put that in a calculator and divided it, this is going to reduce to 3 over 4. All right, so what is a proportion? We just talked about ratios. A proportion is just two ratios set equal to each other. So a ratio equals a ratio. And again, from Algebra 1, hopefully you know what to do with proportions. If you get something that looks like this, we have something called the cross product property, which is where we just cross multiply. So if A over B equals C over D, then we can multiply these together and get that A times D equals B times C. The reciprocal property says that if I have a proportion like this, A over B, C over D, same one as up here, we can just flip both of those, take the reciprocal of both of them. So instead of A over B, it's B over A. Instead of C over D, it's D over C. And this is still equal, this proportion here. We don't have a good name for either of these properties, but there's two more properties when we deal with proportions. One is if A over B equals C over D, we can take the two numerators and the two denominators and create a new proportion. So instead of A over B, A over C would equal B over D. So we just go straight across. We have to keep it in the same order. We have to go this way and this way. We can't go this way and then this way. We have to go in the same order. And the fourth property, this is kind of a weird one. We've got A plus B over B equals C plus D over D if we know that this original proportion is true. Really what's happening here is we're taking A over B and adding 1 to it. Another way to write 1 would be B over B. And we're taking C over D and also adding 1 to it, which we could write as D over D. So if I compared these, or if I added these together, combined them, it's the same denominator, so we can write it like that, which is where this comes from. This, I'm just adding 1 to it. I can write it like that since it has the same denominator. So really all I did was I just added 1 to each of these things to keep the equation even. All right, so solve the proportions without a calculator. When you're solving a proportion, first thing you do is cross multiply. So 3 times 12 is 36. M times M is M squared. To get rid of a square, we square root something. So M equals 6, or we could say M equals positive or negative 6, because technically the square root of 36 could be negative 6. Same thing here, cross multiply. This one's a little bit more complicated because we have 2x for this times this, but then we have 3 times this whole thing. We have to make sure that we distribute when needed when we're cross multiplying. So if you have multiple terms in a numerator or denominator of a proportion, you have to distribute when you cross multiply. So we take 3 times x, 3 times negative 5. So we have 2x equals 3x minus 15. To solve for x, get all the x's together by subtracting 3x. So 2x minus 3x is negative x, negative 15. And then if negative x equals negative 15, x equals positive 15. Over here, this one looks a little bit different. It doesn't look like a proportion because we just have one thing over here. So one thing we could do is write this over 1, just turn it into a fraction and then cross multiply. Another thing we could do is just get rid of this fraction by multiplying both sides by 3. If I multiply this by 3, that cancels out. If I multiply this by 3, that turns into 3k. Essentially, it's the exact same thing because when we cross multiply this anyway, we would multiply 3 and k and 1 and 5k plus 16, which isn't going to change it at all. So this equals this, and then again, we just want to get all the variables together. So 3 minus 5 is negative 2. 16 is left over here. Divide by negative 2. So k would equal negative 8 from 16 divided by negative 2. All right, on the back, not much left. Terms you might hear when you're talking about proportions are means and extremes. So you might hear something like the product of the means equals the product of the extremes. So what does that mean? All it means is if you have a proportion like this, A over B equals C over D, these two numbers we call the means, and these two numbers we call the extremes. Okay, so when we cross multiply, A times D equals B times C, hence the term or the phrase, the product of the means equals the product of the extremes. These two numbers times each other equals these two numbers times each other. So an example of when you might use this, if a problem says, if the means of a proportion are 6 and 12, list all positive integers that could be the extremes. So if you have a proportion, the means are these two numbers here and here. 6 and 12, and we'll say x and y. So it says list all positive integers that could be the extremes. So there's going to be more than one answer here. So if we cross multiply this, we get 6 times 12 equals x times y. 6 times 12 is 72. So we need to figure out, okay, what are the different combinations of numbers for x and y that could get me 72? So the easiest one is if we just had 1 and 72. 72 is also an even number, so we know we can divide it by 2. So 2 times what number would also give me 72? That's what we need to figure out. 72 divided by 2 is 36. So these two numbers multiplied together gives me the same thing as when I multiply 6 and 12. What else goes into 72? 3 goes into it 24 times. If I divide 72 by 3, I get 24. 4 also goes into it 18 times. And then, of course, 6 goes into it. But that's already part of our answer, so we're not going to list that one. And last one would be 8 goes into it 9 times. And then if we kept going, we'd start repeating 9 and 8 and then so on and so forth. So we only have to list that once. Same thing down here. If the extremes of a proportion are 4 and 20, list the possible means. So instead we have x here, 4 here, 20 here, y here. We need to figure out what numbers x and y could be in order for this to work out. So again, we cross multiply. xy equals 4 times 20 is 80. So find the possible factors of 80. Again, first one is the easiest. 1 and 80. So 1 times 80 is going to be 80. So if we put these in here, just to check to make sure, if I plug in 1 over 4, if I plug in 1 and 80, 1 over 4 is the same thing as 20 over 80. 20 over 80 would reduce to 1 over 4. I can also plug it in the opposite order. I can plug in 80 over 4 equals 20 over 1, because then 80 divided by 4, 8 divided by 4 is 2, and then, but there's a 0 here, so this is going to be 20, and then 20 divided by 1 is obviously 20, so that works. So back to this. So different factors of 80, so 1 and 80, obviously. 2 goes into it 40 times. 5 goes into it 16 times. And then 8 goes into it 10 times. 9 doesn't go into it, so if we kept going, we'd go back to 10, 8, and then we'd keep repeating the ones that we had up here. So we're done. All right, and that is it for ratio and proportion.